So with quadratic functions, we talked about this a little bit with the idea of concave up versus concave down. So concave up is where you have something bending upward. So in terms of a parabola, you saw something like this, but you could see just sections of it, and that would still be concave up. So in terms of our graphs down here, in terms of bending upward, that's what we're seeing with those two examples. So this graph right here would be concave up, as would this one. And then concave down is where it's bending downwards. So something that might have this kind of trend, but again, you could just see sections of it, but kind of bending down, those two would be concave down. There are a few different ways that can help thinking about this, like concave up is like a smiley face and concave down is like a frowny face. So you can imagine eyes here for that. I often like to think of it kind of like a bowl versus an umbrella. I mean, this is the Pacific Northwest. We're used to seeing it rain a lot. So when it's concave up, I think of it as something that can collect water. It's going to be like a bowl. It'll hold water. So these concave up scenarios, if it was raining down, the water would gather and build up. Same thing with this example down here. It would be like a bowl where the water would gather. Whereas concave down is kind of like an umbrella. So with this first example, if it was raining, the water would just kind of fall off to the side. It's like we're protected underneath that graph. Same thing with this last example here. If it was raining, the rain would just kind of fall off to the side like an umbrella. So loads of different ways to kind of get used to those shapes coming through in the graphs. An inflection point is where we change between concave up and concave down. So let's see how all of this applies to this graph here. We'll also talk about some other aspects of graphs. So just seeing where a function is positive versus negative. So what we're looking for here is where are the function outputs more than 0 and where are the function outputs less than 0. So our cutoff for that is the x-axis. It's like what would separate it is this line right here. So with that, if I want to see where a function's positive, well, it's this whole region where I'm landing above the x-axis. So we can see is this main point that kind of denotes when we switch from negative to positive is happening at x equals -2. So where our function's positive starts at -2, and then it continues on until we go off to positive infinity, because it's just going to keep going up and stay positive for the rest of the time. Now, we don't want to include the -2 because when x equals -2, our function output is equal to 0, and we don't want to actually include 0. Positive means strictly more than 0, negative means strictly less than. So for my interval, what I'm going to say is that it starts at -2 and then goes off to positive infinity. Then for where a function's negative, well, that's everything over on this left-hand side of -2. So -2, we switch from negative to positive. So our function is negative when x is negative infinity up until -2. So we're going to have negative infinity up to -2. All right. Where is our function increasing? So increasing and decreasing, I'm just going to go ahead and look at this function and read it from left to right. I'm going to start over here and see, okay, increasing, 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 and then it's going to switch. So over on this left-hand side, my function is increasing, then it's going to switch, and they'll be decreasing, 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 until that local minimum, at 6, so between there it's decreasing, and then it'll start increasing off to infinity. So the intervals where my function is increasing is, for x, it's between negative infinity and positive 2, and then positive 6 off to positive infinity. So negative infinity to positive 2 and 6 to positive infinity. And where is the function decreasing? That's between 2 and 6. So the interval between 2 and 6. Again, we're using parentheses here because we don't actually want to include those endpoints, because at that local maximum and at that local minimum, it's neither increasing nor decreasing. All right, where are we concave up versus concave down? So for concave up, I'm looking to fit this kind of upward bending shape, and for concave down, this downward bending shape. So what I could see here for this first part of my graph, I have something that's roughly concave down. And then it's going to switch and have something that's roughly concave up. So this is where the inflection point comes in. If we switch concavity, in this case from concave down to concave up, there's this coordinate in there where that change is happening. Just like how we have this coordinate where increasing and decreasing switch over, same thing with the concavity. And a general rule you can use, it doesn't always work, but it works a lot of the time, is when you have this is a polynomial graph here, it's typically halfway between your local minimum and maximum. Meaning, I'm going to look at this x equals 4 and see my function output, and that looks pretty good as a spot for where this graph is switching over, in terms of having something concave down and then switching to something that's concave up. So that green dot that I just put there would be our inflection point where it switches, where everything to the left of there is concave down, and everything to the right of that point is concave up. Now, similar to our maximum and minimum there, like it's neither increasing nor decreasing at those points. With the inflection point, it's neither concave up nor concave down. So it doesn't have any concavity there. So we're going to treat 4 as the cutoff point. So for concave up, it starts at 4 and then goes off to positive infinity. For concave down, it starts at negative infinity and ends at positive 4. And then that inflection point we just found is the point 4, 6. So this is a coordinate. I know we just wrote a lot of items in interval notation, and that those can look like coordinates, but this is the coordinate 4, 6. That we just drew there in green. So there's some different ways we can think about and describe our graph.